Okay guys, all you're going to need today is your journal, pouch, and calculator. Homework should be in the hot spot. And your red pen's ready to be grading your homework. You're going to grade those first. And then when it's all graded, then I'll discuss what you're going to be doing next. Okay, so as you see, the test for Unit 2 is tomorrow, so we're going to be reviewing in class today. Today's review is a little bit different because it's just questions, and I want you to write down what you're thinking. They're reflective questions, open-ended response questions. So what you'll be receiving is this, where it says Unit 2 Review at the top, Introduction to Functions. Put your name and class period. The way I set this up is by TEK. So this is A12A. These are questions that you need to understand and know to do well on the questions on the test tomorrow that are covered by this TEK. So if you notice, if you flip through all this, you'll notice just a couple TEKs. There's the second one, third, and fourth one. So your test will be covering 4 TEKs. Now your test will actually be multiple choice questions, but again, reflecting on these questions for the review will help you ultimately when you get to those multiple choice questions. So you're going to be working on this independently by yourself for about 15 minutes. Then Miss Osborne will tell you that you'll have the next 15 minutes to discuss with a neighbor or partner if you're stuck on some. And then we will go over the answers the last 10 minutes of class. This is how I want you to work through this, though, because this will be the first time we're doing something like this. If we do the first one, okay, it says, how can you determine if any representation is a function? Give an example. So what I am going to do is I'm going to look through my journal and figure out where this information is located, so that will help me study. So again, we're talking about how do you determine if it's a function or not. So I know this is talking about functions. So I'm going to go look at my page that says relations and functions. Now, as I'm looking here, okay, it says a function is when all the x values are different. Non-function is when there's 2 or more x values that are the same. So that's my answer. How can you determine if a relationship is a function? I'm going to put down that all the x values are different. Now this is your study guide, so yours might look a little bit different than mine, which is fine. Okay, but all the x values are different. It also says give an example. Well, on my notes for the function, we did a couple different examples. We did ordered pairs, we did tables, we did mapping diagrams, and on the next page we did graphs. So I want you to create, you don't have to copy the same one, just create some examples that show that it is a function. Okay, so I could probably, let's do ordered pairs first. So it's a 1, 2, we'll do 3, 5, and we'll do 6, 4. Okay, that would be considered, again, a function because I'm going to show all the x values are different. And you would go on to show a table, mapping diagram, and a graph. And the last thing I want you to do is you can either put your page number, so this is my page 35, so I can go back in my notes tonight and study that page, because I know that's going to be on the test. So again, 15 minutes working independently, then you'll have about 10-15 minutes to work with a neighbor, and then we'll go over the answers before you leave. So go ahead and get started. Alright, now that you've had time to work on this independently, you had a good idea of where you stand on how you're going to do on the test tomorrow. Then you were able to ask your neighbors and check your work with your neighbors. So let's go over the answers on what I had. Now you might have something differently. I might not have added some things that you have had, which is awesome if you have more than me. That just means you're well prepared. Okay, so again, make sure you have the very minimum, which is what I have on my paper. So we did the first one together. Okay, remember that a function is when all the x values are different. So I showed an example of each thing. Remember when it comes to the graph, we use the vertical line test. It should only hit it one time. Okay, the next question was, how do you determine when it's not a function? So this is the opposite of the first one. And this is when you have 2 or more x values are the same. So here's my ordered pairs. Notice that the x value here, 5, is repeated. the table, negative 2 is repeated. The mapping diagram 3, I have 2 arrows coming from that. So if I actually wrote down the ordered pairs for this mapping diagram, I have 2, 4, 3, 5, and 3, 6. And once I write those down, I notice that the 3's are doubled. So that would be considered not a function. And then the last one is a vertical line test. It hits it twice on that function, so that would be considered non-function. Again, this is from Relations and Functions in my notes, my page 35. It could be a little different for you. Okay, it says the next question, when do you use the vertical line test to determine if it's a function or not? That's only on a graph, and I just put down if it hits it one time, it's a function. If it's more than one time, it's not a function. Okay. The next question, how does the vertical line test compare to using the mapping diagram? So this question you could have gone a couple different ways. For the vertical line test, I just put down again, if it hits it more than one time, it's not a function. And it's similar to the mapping diagram, because again, if 2 or more arrows comes from the x value, it's not a function. So if it hits it more than once, it's not a function. If there's more than one arrow coming from that number, it's not a function as well. You could have something totally different, but again, that's the basics out of it. You have to know the difference between when to use the vertical line test and then how to read that mapping diagram. Next page. Okay, the next page says, how do you identify the independent and dependent variables from a table, graph, mapping diagram, verbal description, and coordinates? So remember in our notes, again, this comes from Relations and Functions. This is my page 35. I'm writing that down, so if I have to go back and study that. Independent variables are the x values. Dependent is the y values. Write that down if you don't have that already. Independent are the x's, dependent are the y's. So when we wrote this in our notes, we actually had our xy table and we listed domains, independent, and inputs for the x's. Y's are ranges, dependent, and outputs. Okay? Now since the independents are the x's, okay, whenever I have a graph, my independence would go on the x-axis. Remember we talked about dry mix and how this is related to science, but the dependent stands for the D on the y-axis. The independent stands for the x-axis, so that's one way you can remember. And then I also just wrote down the mapping diagram and the coordinates. Again, x's are independent variables, and the range or the y's are the dependent. Okay, how do the independent and dependent variables relate to a function rule? Again, to make a function, okay, no independent values, which are again the x values, can be repeated. So it's the same thing, it means the same thing, it's just using independent and dependent. Okay, the next one, how do you find a solution for the function? Okay, this is when you might input the x value to find the y value. That's something you could have written down. There's a couple different things you could have wrote down for that. And again, that's a very broad question. It could be, you don't know what the solution's asking you to find, so just put that down. The input, you input the x to find the y, or the output. Okay, the next one was the beginning of notes. This is on my page 44, and we started talking about the words on the little graph. Words for slope here are each, every, and per. So when I'm writing my equation for linear stuff, I know whenever I see y equals mx plus b, the m represents the slope. I might add that too because I don't have that written down on this paper. And the b represents the y-intercept. I want you to write that down. So whenever it comes up in a word problem that says miles per hour, I know that would be considered the slope because I see the word per. The next one is how do you find the y-intercept? What words in a word problem? I listed everything we have in our notes, so you might have a couple, you might have all of them, doesn't matter. starting point, initial fee, down payment, base rate, original amount, and first or one-time fee. Okay, operation, same thing. We talked about sum is the answer to an addition problem. Difference is the answer to a subtraction problem. Product is the answer to a multiplication problem. Quotient is the answer to a division problem. Okay, the next TEK talks about our discrete and continuous graph. So what type of graph is made from only distinct points? Okay, this comes from 2-1 graphing relationships. My page 32, that's a discrete graph. Remember, it looks like a scatter plot when there's just points. Okay, these values can be counted. So the one we use in our notes were, if I sold 1 candle, I earned $5. 2 candles is 10. I can't have a half of a candle. I can't sell a half. So this is when there's no halves, there's no quarters. It's all whole numbers. You can be counted. They're counting numbers. That's a discrete graph. The next one is our continuous graph. So an example we used was cutting the grass and the height. So if it was growing and then we cut it, so it showed that it went back down to the normal. Then as time went on, it grew again, then we cut it. Then it grew again and we cut it. Okay, so that's a continuous graph. The growth of the grass continues as the time goes on. Okay, the next question, which variable will you plot on the x-axis? Well, if I'm on the x-axis, that's going to be the x-intercept. It's going to cross over and intercept the x-axis. The variable that you plot on the y-axis is going to be the y-intercept. Okay, so the next one I actually drew pictures. It says, what is the value of y at the x-intercept? So here I drew an x-intercept. It crosses over at the x-axis. And if I actually labeled that point, it would be 2, 0. Okay, which means that the y value is 0. The y-intercept, okay, crosses over the y-axis. That means the x variable is 0. Okay, and then the last page. First question said, what is the 0 of a function? And remember, I told you that this is the same thing as something else. 0 of a function is the x-intercept. You're going to see a little bit of both of these written down. So again, just wherever it crosses over the x-axis. 0 of a function is the x-intercept. Okay, the slope of a function is our constant rate of change. Okay, it's the change of y over the change of x, and we figure that out using rise over run, which we'll work into the next unit. Unit 3 is all about slope and how to find slope using multiple ways. But the slope is what's happening every single unit. Is it going up? Is it going down? It should be a constant rate of change. Okay, this goes along with this first question. How are the zeros of a function and the x-intercepts related? They're the same thing. Okay, same exact thing. Okay, function notation. This goes under the TEK A.12b. Function notation is really just our f of x. It means the same thing as y. Okay, it just means that the equation is a function. All the x's are different. Function notation is f of x. Okay, what does f parentheses 3 mean? That means f of 3. So what they want me to do is whenever there's an x in the equation or the function notation, I'm going to plug in 3. I'm going to input 3 as the x value. Okay, how would you compare and contrast y is equal to 3 and f of x is equal to 3? Same thing. Remember, f of x is the same as the y. F of x is the same thing as y. Okay, the next question, what is another way to think of domain and range? Domains, remember, are the x values always. Ranges are the y values, and remember I wrote down this just to be funny. To remember that, if you live on the range, you probably say y'all a lot, so y for y values and y'all. Okay, the next question is, what's the difference in domain and range in a function and a real-world situation? And I put graph too. Remember, when it comes to a graph, we have to write it as an inequality. When it comes to just maybe a table or ordered pairs, we can just list them out. But what I would really focus on is writing them as inequalities. Next question, how do you determine if the domain and range is continuous or discrete? Remember, continuous means it's a graph, and discrete is probably when it's just specific points, so that comes from a table, coordinates, mapping diagram, anything like that. Then the last question is, how do you write the domain and range using inequalities? Remember, our domains are always the x's, ranges are always the y's, and we always find our lowest domain and our highest domain, and we put all the x's, or all the x values that represent the domains have to fall between there. Same thing with the y's. The lowest y value, the highest y value, all the y's have to be the same. Another thing I would add is if it's a closed circle, what symbols do we use? Greater than or equal to, or less than or equal to. If it's an open circle, it's just greater than or less than. Again, you might have added some more stuff, which is fantastic. Good for you. So, what you're doing tonight is studying over this review. You're looking through your notes, looking through all your worksheets. So if there's any papers in the handout tray, make sure you guys hand those out so you have those to study tonight. And tomorrow you'll start your test right away over Unit 2. And then at the end of your test, if there's extra time, you'll have something to start working on for Unit 3. So take your time tonight, study hard, and we will see you tomorrow. Have a great day.